All right, so welcome back. We're going to do these three practice problems so you can check your answers. I'm going to go through them a little bit quicker. Remember, our formula is y2 minus y1 over x2 minus x1. Y's above x's. This is negative 2 minus 2 over 5 minus 5, which gives us negative 4 over 0. And remember, we can't divide by 0, so this is undefined. For b, we have 4 minus 4 over negative 3 minus 0, which is 0 over negative 3. And when the 0 is in the numerator, that's 0. Finally, we have negative 4 minus 6 over 5 minus 0 equals negative 10 over 5, which reduces to negative 2. So there you go. Hopefully those three came out all right for you. If they didn't, right, you need to stop what you're doing right now. You need to talk to your teacher and ask questions about this, right? Don't move on if you don't understand. If you do, though, let's continue. Let's talk a little bit about classifying lines by slope. So depending on what kind of number you get as your slope, you can tell if a number is rising, or excuse me, if the line is rising, falling, horizontal, or vertical. And we kind of talked about these a little bit already, at least the horizontal, or in the last video. So again, on the horizontal, if you have 2 points that are directly left and right of each other, this kind of looks like a face. Uh, you get a horizontal line. And horizontal lines, as we saw in the last one, have the same y values, so you end up with 0. So a slope of 0 is a horizontal line, okay? And again, as we saw in the last video, when we have two vertical lines, or 2 points that are vertical, we end up with an undefined slope. And an undefined slope is a vertical line, right? So undefined ends up being vertical, horizontal lines end up being 0, okay? And that always happens. If you get a 0 slope, it's horizontal. If you get an undefined slope, it's vertical. Rising slopes will always occur when, as you're moving left to right, the numbers are increasing. The point is getting bigger. Okay, we should always kind of think of this as looking at it left to right. If it's getting bigger, then this is rising. This is a positive slope. Right? I like to think about it as if you can write your name on it, whoop, and it's going up. See, there's my name. Right? My name is going up. That's a positive slope. Okay. Whereas if I write my name on a thing that's going down, right? It's hard to write sideways on this thing. That's a negative slope, right? It's falling. My name is going down as it moves to the right. That's falling. If it's up, it's that. So a rising is a positive slope, and a falling is a negative slope. So we can kind of go back and look at some of our previous examples to say, what is this? Well, this is undefined, so it's a vertical line. This one's 0, so it's a horizontal line. This is a negative, so it's a falling line, right? We've got a horizontal and a vertical. This is a positive, so it is a rising line. And this is a negative, so it's a falling line. Okay, so you can see that in the pictures on all of these as well, right? Horizontal, vertical, etc. Vertical, horizontal, falling. So depending on the number, we can tell if a line is rising, that is going up, falling, going down, horizontal, straight across, or vertical, straight up and down. All right. So we know these things about slope, okay? So let's talk about our last thing here, and this is rate of change. And a rate of change is basically the same as slope, right? We're calling it a different word, but it means the same thing, okay? A rate of change compares a change in one quantity to a change in another quantity, right? You should read this as a change in y versus a change in X, right? The only reason why we're saying one quantity versus another quantity is like in context, it's sometimes better to say rate of change because that gives us a sort of a contextual example. All right. So speaking of, right, here's an example. The table below shows the cost of using a computer at a local internet cafe for a given amount of time. What is the rate of change in cost with respect to time? So I can look at the amount of time that's gone by versus the cost, and I can determine a rate of change. If I were to look at these two numbers, I can see that as 2 points, 2, 7, and 4, 14. Okay, the time being our x, the cost being our y. And I can find the slope between these 2 points. y2 minus y1 over x2 minus x1 gives me 14 minus 7 over 4 minus 2, which is 7 over 2, which as a decimal is 3.5, right? So the cost between these two is 350 per hour. 350 per hour. And we can check that to see if it's the same by checking these 2 points, which is 4, 14 and 6, 21. So again, 21 minus 14 over 6 minus 4 gives me 7 over 2, which is 350 per hour. So how much does it cost to use the internet at a computer at this internet cafe? It's $3.50 per hour, okay? And we can see that in the table. For 2 hours it's 7, for 4 hours it's 14. Clearly, every 2 hours that I work, or that I'm on the computer, I've paid $7, which means $3.50 per hour, right? It's the change in one quantity, time, over the change in another quantity, cost. All right, there is one more example of this for you back on your canvas. Please go do that by yourself and on your own first. Do not watch the next video until that's done, right? And then you can check your answers in the final video.